Good morning to one and all. In the yesterday's class, we started carbon and its compounds. Already we discussed the importance of carbon and Sp3 hybridization formed in carbon compounds, particularly in methane. All of you know the valency of carbon is 4 and the number of valency electrons in carbon is also 4. It's a non-metal. Today we will start Sp2 hybridization and also Sp hybridization. These two concepts, we will go through these two concepts now, which are very important. Now, what is Sp2 hybridization? See this Sp2 hybridization. The compound, the bond form Sp2 hybridization formed by ethene, that is CH2 double bond CH2. So first of all, you know the electronic configuration of carbon is 1s2, 2s2, 2p2. That means 2px1, 2py1. In the excited state, it becomes 1s2, 2s1, 2px1, 2py1 and 2pz1. By intermixing one s orbital and two p orbitals and reshuffling to form 3 sp2 orbitals. So if you go for sp3 hybridization, in that 1 s orbital and 3 p orbitals, whereas in sp2 hybridization 1 s orbital and 2 p orbitals. sp3, s means 1 s orbital, p3 means 3 p orbitals, sp2 that means 1 s orbital and 2 p orbitals, and they are intermixing and reshuffling to form 3 sp2 orbitals. Now observe the small diagram. 2s orbital, 2px1, 2py1, 2pz1. So 2s orbital is a lesser energy than 2p orbital. That's why I have give a small difference in the heights. Now after intermixing and reshuffling, there are 3 sp2 orbitals and there is a separate 2pz orbital. These 3 orbitals are sp2 hybrid orbitals, and that 2pz orbital is unhybridized orbital. What is the unhybridized orbital in this sp2 hybridization? That is 2pz, that is particularly in ethene. Now go for the next concept, next point. Each carbon atom is left with one p orbital, that is pz, unhybridized. In each carbon atom, if you consider any carbon atom, you know the electronic configuration of that carbon atom, you know the excited state of the carbon atom. After hybridization, after sp2 hybridization, there is one unhybridized orbital. What is that unhybridized orbital? That is 2pz. So in each carbon atom, there is one unhybridized orbital. 3 sp2 orbitals having one electron each get separated around the nucleus of carbon atoms at an angle of 120 degrees. So 3 sp2 orbitals, this is carbon, 3 sp2 orbitals having one electron, each are having one electron, get separated, these two are separated around the nucleus of carbon atoms at an angle of 120 degrees. Now this is about the sp2 hybridization, the first part. Next you go for the detailed information. One sp2 orbital of carbon atom. Now you see, one sp2 orbital of carbon atom overlaps with sp2 orbital of another carbon atom to form sp2 sigma bond. Very simple statement. You can write the statement easily. One sp2 orbital of carbon atom. You know, in every carbon atom, how many sp2 orbitals are there? Previously you studied about that. That is 3. There are 3 sp2 orbitals. What about the first sp2 orbital? Suppose if you are taking carbon, one sp2 orbital of carbon atom overlaps with sp2 orbital of another carbon atom to form sp2 sigma bond. sp2 sigma bond. If you observe that, you will easily find out that. Just you observe this. This is sp2 sigma bond. Okay, that is sp2 sigma bond. Next, okay, the remaining 2 sp2 orbitals of each carbon atom get overlapped with s orbital of 2 hydrogen atoms. The remaining 2 sp2 orbital of each carbon atom get overlapped with s orbital of 2 hydrogen atoms. Now you consider this. I will explain. See this. This is another sp2 orbital. This is another sp2 orbital. So there are 2 sp2 orbitals. These two are sp2 orbitals. These 2 sp2 orbitals are these two are the sp2 orbitals of this carbon atom. These two are the sp2 orbitals of this carbon atom. These two are the sp2 orbitals of this carbon atom, and these two are the sp2 orbitals of this carbon atom. These are overlap with hydrogen atom, s orbital of hydrogen atom. This is 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 s orbital of hydrogen atom. Okay, s orbital of hydrogen atom. Now the remaining 2 sp2 orbitals at each carbon atom get overlapped with s orbital of 2 hydrogen atoms. Now that is sp2 S hybridization. That is also sigma bond. Next, what about the pz orbital? The pz orbitals that are unhybridized of 2 carbon atoms overlap laterally. Laterally ante prakka pakkana. Laterally to form pi bond. End on end overlapping is called as sigma bond. Side on side overlapping is called as pi bond. Just you observe this diagram. This is pz orbital and this is pz orbital. These 2 pz orbitals are overlapping laterally, forming pi bond. Okay. So finally, in ethene, sp2 hybridization is formed. So how many sigma bonds are there? 1 sigma bond, 1 sigma bond, 1 sigma bond, 1 sigma bond, and 1 pi bond is formed between 2 carbon atoms. Between 2 carbon atoms, 1 sigma bond and 1 pi bond is formed. And how many sigma bonds totally? This is carbon, this is hydrogen, 1 sigma bond. This is carbon and hydrogen sigma bond. Carbon and hydrogen sigma bond. Carbon and hydrogen sigma bond. Carbon and carbon sigma bond. In the examination papers, they asked in different ways. How many sigma bonds are formed in ethene between 2 carbon atoms? The answer is 1. How many sigma bonds are formed between carbon and hydrogen in ethene? Then 4 sigma bonds. How many sigma bonds are there in ethene? That is 4 plus 1, which is 5. 5 sigma bonds. So how many pi bonds are there? Only 1 pi bond. So without sigma bond, there is no pi bond. Now you observe this diagram. In this diagram, sigma bond sp2 sp2, sp2s, sp2s, and pz pi bond. So there are 5 sigma bonds and 1 pi bond, and this compound name is ethene, IUPAC name is ethene. IUPAC name is ethene. What is the common name? Ethylene. So how many bonds are formed? 6. How many pi bonds? 1. How many sigma bonds? 5. సో హైబ్రిడైజేషన్ అంటే కొద్దిగా కష్టమైన కాన్సెప్ట్ అని చాలామంది భావిస్తుంటారు. కాబట్టి దీంట్లో హైబ్రిడైజేషన్ కనుక బాగా అర్థమైతే చాలా సింపుల్. ఇందాక ఎన్ని హైబ్రిడైజ్డ్ ఆర్బిటాలు ఏర్పడ్డాయి, ఇందాక ఎన్ని హైబ్రిడైజ్డ్ ఆర్బిటాల్స్ కానివి ఏర్పడ్డాయి, ఇప్పుడు ఎన్ని, అట్లా చూసుకోవాలి. నెక్స్ట్ ఈ డయాగ్రామ్ బాగా ప్రాక్టీస్ చేయండి, నీట్గా ఉండాలి. నాకు డయాగ్రామ్స్ అంతా క్లారిటీగా గీయడం రాదు. సో మీరు ఇంతకంటే బాగా బెటర్గా డయాగ్రామ్ స్కెచ్ చేయండి. ఓకే, నెక్స్ట్ I will go for next concept, that is Sp hybridization. That is Sp hybridization. What is Sp hybridization? Okay. Now, what is the example for sp3 hybridization in carbon compounds, particularly methane? The first example is methane. In methane, what hybridization is there? sp3 hybridization. In methane, how many sigma bonds are there? In carbon and carbon, 3 plus 3 plus 6, 6 plus 1, 7. Similarly, in what hybridization is formed in ethene? Just now we completed Sp2. Now you go for Sp hybridization. Sp hybridization. What is Sp hybridization? So the example for Sp hybridization is ethine. Okay. So the electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1. In the excited state it becomes 1s2, 2s2, 1s2, 2s1, 2px1, 2py1, 2pz1 by intermixing one s orbital and one of the p orbitals and reshuffling to form two sp orbitals. So by intermixing one s orbital, so here one s orbital and only one p orbital, one of the p orbitals, it may be 2px, 2py or 2pz, one of the p orbitals, you can write like that, and reshuffling to form two sp orbitals. Okay, s orbitalu p orbitals lo ఏదో ఒకటి కలిస్తే వచ్చేది sp hybridization. డయాగ్రామ్ మనం చూపిస్తున్నాం, డయాగ్రామ్లో జాగ్రత్తగా గమనించండి. సో 2s, 2px, 2px1, 2py1, 2pz1. Here 2s, 2s1, 2py1, 2px1, 2py and 2pz. Those are arranged separately. That means those are not hybridized orbitals. Those are not hybridized orbitals. So now each carbon atom is left with two p orbitals unhybridized. మనం ఇందాకటి ఆన్సర్ ఎట్లా రాసామో ఇప్పుడు అదే